seats and get ready to start, okay? Alright. Everybody smile. Everybody smile. You're happy to be here. Now, everybody just smile. Smile's quiet. Okay. Alright, so if you would grab this first problem. And let's work that out and check it with multiplication. Check it with multiplication after you get finished. It's always a nice feeling when you check it and you've gotten the right answer. But if you haven't, you can figure out maybe where you went wrong. Getting started, so just grab your whiteboard when you get a chance. You don't have to work this first one because we're just fixing to check it. Just wait till the next problem, okay? Okay, finished? Good question. Alright, so how many eighths, Caleb, how many eighths can I get out of 53? Because I'm going to have to go to 53. So you say 6. 6 times 8 is?
48.
48. Is that the most? Because 8 times 7 is 56. So 6 is the most I can get out. And that would make me subtract 48. Okay? When you subtract 48, you're going to have to do some borrowing here. 13 take away 8 is 5, and then bring down the 8. Alright, so you might have had to been kind of patient and make sure you get all those little steps inside of this problem correct. So now you've got 58. How many eighths, or what's the most eighths I can get out? Yeah. Okay. 8 times 7 is 50. What? 56. And that's pretty close. Close as we can get. And we'll get 2 left over and then bring down this 2. All right. So how do we finish this off here? How many eighths can we get out of 22? What's the most? Yeah. 2. Just 2. And that's 16. Again, we've got to do some borrowing. 12 take away 6 is 6. Can we have a remainder that large? Yeah, we can, as long as it's smaller than our divisor. Okay, because we cannot get a group of 8. If it was, if it was 8, I could get a whole nother group of 8. But it's not, so that's going to be our remainder. Let's check it. 672 times 8. 8 times 2 is 16. 8 times 7, 56 plus 1 is 57. This is 48, 49, 50, 51, 52, 56. Plus 6. 5,382. Okay. Anybody have a question or a comment? Something you want to say that might help us all? We're raring to go this morning. It's like we get to Thursday and we get new energy because we can see the end of the week coming. Okay, but we still got to work hard to get there. So, somebody yesterday, maybe it was in here, said it's already whatever o'clock. You know, we had been working on math. We had worked hard yesterday. Was that you? And sometimes when you work hard, the time flies, and you've gotten through the day quick. Yeah.
What I didn't do it on my division, but I did it on multiplication.
Okay.
I didn't add the 1 to 7, so it kind of got my answer off a little bit.
Look at my 1. It's just kind of thrown up there in a messy way because I'm doing it fast. Where I carried my 1, see 6 plus 6 is 12. Put the 2 and carry the 1. And if you're not careful, you might not add it in. You might not see it. A lot of times the carrying, the borrowing, that's where our little mistakes happen, is in little things like that. Okay. Let's try one more at least. Let's go here. What does that big empty space in the middle of those two fractions mean? What are they wanting to know? Yeah. Compare the fractions. Which one is larger? And we know several methods to do that. And you can choose any method that works for you best. Okay, so you're going to write those two fractions and then figure that out. Which one is largest? Use one method, but then you want to check yourself with another method. Wow, a lot of different methods being used across the room. Ishmael, which way did you use? Anybody else use heart method? I did see that in several places. Okay, using the heart method, which one did you see was bigger?
2 and 2. The 1 to 2.
1/2?
No, 2/3.
2/3 is bigger. Okay. Who used a different method? And maybe how many of you agree 2/3 is bigger? Let me ask that. A lot of you. Okay. But he used the heart method to give him that answer. Who used a different method? Okay. Isabella, what method did you use? Steal it and hide it. Okay. Steal it and hide it. Raise your hand if you used the steal it and hide it method. I saw that in several places. Okay. Did it give you the same answer? That this one is larger? Yeah. Okay. Who used something else? Yeah. Reasoning. You can do that one on this one. You know, there are certain problems that reasoning is a lot harder to do. This one, you could, because you've got 1/2. There is one of our benchmark numbers, and then 2/3. Is 2/3 going to be larger than 1/2 or smaller than 1/2? It is larger. It is larger, especially if you know your fraction pieces pretty well. So you could have used reasoning. Anybody use another method? I did see somebody draw a number line. I don't know if they used that for, to check themselves, but I did see somebody at least try that. All right, good job on that one. We're gonna jump over the last one there and go ahead and move into our lesson. Okay. Yesterday we were adding and subtracting fractions, and we added a little bit to it. I had to really work to keep y'all with me. There was kind of a lot of new steps to talk about yesterday, even though by the end, y'all were flying through it. Okay? So if I went here and asked you to do that, might as well get this over with now, right?
She took a new one yesterday.
Okay. It looked new. It looked fresh. Okay. If I ask you to take, make that a little bit wider, this number here, and subtract, hold on. Okay. How would you do that? This is not what we're doing today. I simply want to make sure we're remembering what we did yesterday. Okay? Without using a tape diagram or a number line or any of those things. Yeah. You wouldn't? Well, that's going to help you. And you weren't here yesterday to learn this method, so watch what we did. But the denominator is definitely going to help us. Okay? What would we do first in doing it the way we did it yesterday? Okay, what would we do first? What's the first step? Yeah.
We would make a number ball with the 3.
Okay. Because see, we know that this 3 has a bunch of fifths in it. You know, somebody yesterday, we had a problem on the board and they went, that's like 20 fifths right there. And if you counted this up, 3 whole pieces, and each one of them has 5 fifths, 5, 10, 15, that is 15 fifths right there. So if somebody looks at that and goes, I don't have enough fifths to do that subtraction. Oh, yeah, you do. You got tons of fifths. You just got to get to them. So the denominator is important, and this is why. We need to make this have a denominator like that one so we can subtract easier. So what we did, Ishmael, yesterday, let's see, I don't need that. I need this right here. Is we made a number bond. If this was a whole number like this, we made a number bond. And we gave this a new name, okay? What is that one's new name? I'm going to take one away. Yeah, what would this other one be? 5 fifths. Because what's true about this right here? Yeah.
It equals 3.
But this right here by itself equals what? 1. Ah. Come on. Come on. We got to have a little more energy than we did yesterday. Seriously.
Kate, you have to do it this time.
Here we go.
You have to.
Come on, Brenda. We need your help. All right. Any number
Any number
over itself
over itself
is equal to 1.
is equal to 1.
Cha, cha, cha.
Cha, cha, cha.
All right. That was better than yesterday, so I'll let you get by with just that one time. Okay. So, Ishmael, if this is 1 and this is 2, what is 1 plus 2? 3. So it equals that, right? So this is just another way to say 3.
Your hair's
I know. I just saw it out of the corner of my eye. When I turn around, it's going to be there, isn't it?
Yeah, I like
Might
the
as
hair.
well. Might go big or go home, right? There we go. Okay. Okay. Art lesson for the day. You can call anything art. Okay. So now we have 2 and 5 fifths. What do I do with that 2 and 5 fifths? Now what can I do a little easier? Go ahead.
Subtract the 5 fifths.
Yes. What did I say yesterday was one of the things that it's an easy mistake to make?
2.
Do you remember? It has something to do with that too.
To carry it to.
Yeah, that whole number can come over here, can't it? And somebody yesterday, I think they're big on the word method now in second period, like the heart method, the steal it and hide it method. So they called this the banana method. To remember, and somebody said it's the smile method. Just to remember to bring over that whole number. So if you want to draw that arrow, you can. You do not have to. I just want you to remember to bring that whole number to the other side. But hold on, we're almost there. But now we're going to subtract the fraction. We can finally subtract the fraction piece. So Valerie, if I have 5 fifths, I take 3 away. What am I going to have?
2.
Yeah, 2 fifths. So there's my final answer. So it's not tough, it's just there was all those little parts and pieces to figuring that out. Okay? All right, so let's go back here for just a second. We're not doing that today. Okay, we're moving on to something else. Now, might we come back to that later? Yeah, but not today. Okay? I can add and is my pen still up? No. What is this word right here? Multiply unit fractions to build fractions greater than 1 using visual models. Okay, so we are going to have some visual models. We are going to be, when I say multiplying fractions, does that make you a little bit nervous? A little. I'm going to tell you a lot of people love multiplying fractions and find it way easier than the other fractions do. Okay? So, and especially today, because today there are fractions. Look what kind of fractions we're working with.
Oh, yeah.
All right, remind me of what that is. What is a unit fraction? We went over this a whole lot. Mason, what's a unit fraction? Okay, numerator, always 1. You always know what the numerator is with a unit fraction. It's 1. So we're going to see that a whole lot today. Okay. I'm going to actually go to a board where I have just a little bit more room. I will put this same information up there. What am I doing? Here we go. Buttons, buttons everywhere. Okay. So on your board, if you would work slowly with me. We're going to kind of step by step together right now. Usually I'll show you something and then we'll do it together, but right now we're just going to work through it together. So get your marker ready, and if you need to clear it off, clear it off. Okay. So let's go ahead and put a number line. We want some space to write, maybe above it. Sometimes we like to write below it. Just make sure in one of those spots you've got some room to write. Now we're going to start at 0. We're not going to put an ending point just yet. That'll come in just a minute. Okay? All right. So what we're going to show first is this right here. So write this at the top of your board. Okay. You were back in 3rd grade when you first learned this. So I'm not sure is it Miss Sarah or Miss Danielle that pulled out number lines. Did y'all have number lines last year?
Yes, ma'am.
Sometimes with addition or multiplication. Okay. That would seem right. All right. So what we're going to do is that's our problem. But let's go back to our number line, and we're just going to number it with or mark it with whole numbers. I don't want them too close together because I want to be able to see everything really clear. Let's go to 7. Okay, that's probably a good enough number to stop at. Okay. Now these are just regular old whole numbers, or counting numbers. Okay. All right, finish that up in 5, 4, 3, 2. Write your numbers. 1 3/4, 1/3, 1,000,000. 0. Okay. All right, trying to help you. All right, so we have this number line. We're going to show this on the number line. We're going to show, you could think of it as 6 2 times, but we're going to think of it as 2 6 times. Okay, we're going to let the smaller number be the amount that we jump. So here we go. We're going to start at 0, and we're going to jump to 2. And then where are we going to jump?
To 4.
To 4. You know what? We made a boo-boo when we made the number line. Okay. Yep. The number line needs to go to a different number.
8.
It's all right. This happens.
I figured it would.
Okay. Well, let's go to 13. Okay. So at least we're not on pencil paper here. Most of us. Sorry.
That's gonna be hard.
You can flip it over if it's easier to just redo it.
I better make the biggest numbers out of every
All right, let's go to and do your best to have a little space between those numbers. I know I'm asking you to put more on there. We're going to number to 13. Okay. And then I'm going to put that back in case you erase that. Put that back. All right, we've got it numbered in 5, 4, 3, 2, 1. All right, and 0. You're with me. Okay, we're going to show this problem happening. Now, we could show it two ways. Let's do the way we had started just a second ago first. Okay, so we're going to jump 2 6 times. So we're going to go to 2. Then y'all said we're going to 4. What comes next? 6. What comes next? What? 8. Then 10. And then what do we land on? 12. Now, double check how many times you jumped. 1, 2, 3, 4, 5, 6. Okay? 2.
1, 2, 3, 4, 5, 6.
This is 2 6 times. Okay? Now, could we have done 6 2 times? Okay, don't add this to your board right now. Just look at it. I could have done this right here, 6, and then 12. But it's a little easier. We're a little better at counting by 2s than we are by 6s. And so sometimes you grab what's easier for you to count by. Okay? But both of those would have worked to get me the right answer. What is the right answer up here? 12.
Wait, so this is past.
Okay?
But I knew it's 6.
All right. Now, I want you to very carefully listen to what I'm going to ask you to do. We're going to erase part of this. Do not erase your whole board. I want you to keep your number line. I think you can do this. If part of it gets erased, just add it back. We're going to get rid of the jumps, but keep the number line. Okay, so if you can get rid of your jumps, and then if something gets erased, just draw it back. Okay. So I'm going to have to do a little repair work here myself.
I don't.
All right, so now we still have our same number line, but we're going to show if I asked you to show this math problem right here with a repeated addition, what would it look like? Reach way on back to 3rd grade. Okay, write that out on your board. How many times are we adding 2 there?
7.
6 to get 12.
You wrote 7.
1, 2, 3, 4, 5, 6. Okay. All right. So y'all learned in third grade repeated addition is the same as multiplying. Okay? So let's change this. Keep your number line, but let's change our math problem. Okay. Here is our new math problem. Okay, so write that at the top of your board. We're not messing with the number line just yet. Okay, just write that problem down. Alright, so what I want you to do now is to look at this, and I want you to write this as repeated addition underneath it. What would that look like as repeated addition? We just did that with our 2's. Now we're doing it with 1/2. Go ahead and write that down. This is not 2 plus 2 plus 2 plus 2 anymore. It's what? Half. Do that 6 times. What are we adding 6 times?
1/2.
1/2. Okay. Make sure it's 6. Sometimes you gotta double check if you've written it down correctly. Okay. Yeah. All right. So one other step that I want you to do, we are going to put this on well, let's go ahead and do that, and then we'll do this other thing. All right, so let's put this on the number line, except what is our number line going to need to make this easier to put on there? What's it going to need? Yeah.
Fractions.
It's going to need some fractions. What fractions should we add to our number line to make this easier? What do y'all think? Look at your number line.
1/2.
Okay. So we're just going to add 1/2 and be done. Right? What do we need to do?
Write 6 times.
Well, if I put 1/2, guys, get with me. Okay. If I put 1/2, if I marked where the halfway point is between the first 2 whole numbers, what do I need to do? Yeah.
Mark the halfway point in the middle of all the whole numbers.
Yeah. Now, I'm not going to ask you to write the fraction every single time, but I do want you to go and mark the halfway point between each whole number. You know, if we had thirds, we'd cut 3 pieces between each whole number. If we had fourths, we'd cut 4 pieces between each whole number. With halves, it's kind of simple. You probably could have just looked where about halfway was, but now we've got it marked, so this becomes a lot easier. So now we're going to show the jumps. 1/2 6 times. Okay? So let's show that. Let's start at 0, and we're going to jump to that half, and then go another half, and then go another half, and another half, and another half, and another half. You should have 6 jumps. Okay? 6 jumps. When you made those 6 jumps, what number did you wind up landing on? If you jumped 1/2 6 times, Bailey, what number did you land on? 3. Valerie landed on 3. Anybody else land on 3? That's where you should have landed. Okay? Go back up to your math problem that's repeated addition. Okay? Y'all see that? Go back to that. I want you for just a second to mark it. We're going to put parentheses around each group of fractions that equals 1 whole. How many halves does it take to make 1 whole? Just two, right? 1/2 and 1/2. Put them together, you got one whole. Look at our pizzas here. 1/2, 1/2. It just takes two of them to make one whole. Okay. So right here, these two would make one whole. Okay. Go find each group that would make one whole. These two would make one whole. Okay. Is there another group there? How many sets of parentheses did you make? 3. Okay. This made one whole, this made one whole, this made one whole, and you know that matches our number line, doesn't it? Okay. So all we're doing with our number line is creating a visual for what happened when we multiplied. Okay. We just made several jumps down the number line. Now these were fractions. How do these jumps look compared to the jumps we made a few minutes ago when it was whole numbers? Is there a difference in how they look? Remember the number line before. Yeah, what do you think? The jumps are what? Before or now? Yeah, definitely. These are smaller, aren't they? Well, think about fractions. They're smaller pieces. This is a whole number right here. All of these other pieces. Okay, this is a whole number. All of these other pieces are fractions. They're all smaller than this, aren't they, if you took them by themselves? So these jumps, these fraction jumps, are usually smaller as long as it's not like a big mixed number or something. Okay? Or an improper track. Okay. So that's something that the number line helped us notice. All right. Now that we've used a visual model to kind of see what's happening, we're going to get rid of our visual model. So would you please erase your board? There may come another time down the road where we say, hey, let's take this multiplication problem with a fraction and let's put it on a number line. Let's create something to look at, but I don't know if you'll find that necessary. Okay? I'm glad we did it at first, but right now we're going to move on. Okay? So, if I put on the board this right here. What we have here is a whole number times a fraction. And today we're mostly dealing with unit fractions. What do you think the multiplication would look like? Think about what you know about addition. Think about what you know about multiplication from 3rd grade or just regular multiplication. How do you think this is going to look? When we make the answer, do you think there's anything special we're going to have to do to get it ready to multiply? Or do you think there's what might be our first step? And I know we're totally guessing right here because this is new. It's okay. Are we allowed to guess?
Yes.
Yeah. Are we allowed to be wrong?
Yes.
I hope so because I make mistakes all the time. What do you think? You think repeated addition? Okay, please put your marker down because nobody's giving you directions for anything right now. Okay, we're not decorating our board. Maybe repeated addition. What else could possibly be involved in this? It's okay to guess. What do you think might be part of this? Any other thoughts? Well, right now, since we're multiplying, that might be a way to check our answer because we know they work together sometimes, but there's really not going to be much division. Yeah?
Will it work like we'll multiply 4 times 8?
Okay, you're wondering, will the denominator get multiplied this time? Is that what you're wondering?
Yeah.
Okay.
Or the numerator will it?
Is it the numerator? Is it the denominator? We don't know yet. Here we go. It's the perfect time.
Dun, dun, dun.
Okay. Any other thoughts?
I thought you forgot.
Okay, go ahead.
So maybe the answer you could think of like how many of the 8s you need to make Because you know 4 and 8 are like a fat family because like 2 times 4.
Oh, I see what you're saying. Okay. Now, y'all are saying some good thoughts. Some of your thoughts might be mixed in there, but most of them are not. Okay? I want you to watch, and I need every eyeball looking right here. I don't need you to blink. You ready? Done.
Huh? Oh, that was I knew it.
I'm done.
I knew
Except,
it. So you were right.
hold on. Except, I need to change my answer to the right form, don't I?
Yes.
What is it right now? It is an improper fraction, and I do need to change this to a mixed number. But how many times does 4 go into 8? So I guess there's division when you change it to a mixed number. What would this be?
2.
I can pull out 4 how many times from 8?
2 times.
2 times. So this is 2. Okay? No, hold on. I know the anticipation is great. So let's watch another example. There we go. Okay, nobody blink. On your mark. Set. Done. Okay, now, some of you are like, whoa, what is happening? Tell me what I'm going to have to do when I have a whole number and I have a fraction. Tell me one thing I'm going to have to do here.
Do 7 times what the numerator and
Okay. We kept the denominator, didn't we? Or at least it seems that way. Okay, and I got to say it that way on purpose. What did we do to the numerator? You said it. We multiplied this number, this whole number, by the numerator. Okay. Now, I'm going to give you a little side note right here, especially those of you that really do like math. And deep down, it's one of your favorite things. Okay. Okay, I need your eyes, guys. If this is a whole number, just a regular old 4, there really is a denominator there. Any whole number, and you're going to use this as you get older, so I know you don't really need it right now. I'm not trying to confuse anybody, but some people this is helpful to know. Any whole number actually has 1 as its denominator. Because this is why this is true. 4 divided by 1 is 4. Okay? So, when it comes to multiplication, if this is this right here, and I put 7 over 1, if I changed its name right here, in multiplication of fractions, wow, I wrote that really high, didn't I? You actually do multiply the denominators together. You're going to see that as you get into like 5th and 6th grade and you multiply fractions beside fractions. Now in 4th grade, it's really mainly a whole number and 1 fraction. So it's really simple. As you get older, you have 2 fractions to multiply. But when you do, you multiply these and you multiply these. So the denominator does get to do a little, most of the time the denominator just sits there and stays the denominator. But he does get to multiply.
But he changes a little bit.
It can change. It can change when this, if this wasn't a 1, it would change it, wouldn't it? Okay. So a lot of people like multiplication because you don't have to remember to keep the denominator the same. You just multiply. Okay. We don't have to worry about this right now. But I just wanted you to know any whole number does have a denominator. You just don't see it. There's really no need to show it. So it's just a 4. Okay. So let's just keep this simple. Don't want to add too much thought there. But this becomes super, super simple. I think it will take you longer to change your answer to a mixed number than it will to come up with your multiplication answer. Okay? Yeah, a lot of you had some good thoughts there. What is 7/3 when we change it to a mixed number? How many times can I pull out 3/3 there? Ishmael, how many times? What now?
2.
Okay. So 3/3, 3/3, and then there's 1 left. So that's 2 1/3.
And it doesn't even take that long.
And y'all are getting faster at this part the more you do it. So it really doesn't take as long as it did, if we were just starting out.
In
Changing
third
this.
grade, I never knew like how a number bond really worked.
Oh, we're using them all the time, aren't we?
Yeah,
Okay.
now I know.
Okay. Here we go. Get ready. We're going to do this together. All right. So we're going to multiply 13, times 1/5. Okay. Now I want your answer as a mixed number. We are going to do that number bond at the end with our answer. You will see that most of the time because a lot of, when we multiply, we get this larger numerator a lot of times. Now, especially since we're using unit fractions today, we're multiplying by 1, aren't we? So that's really simple today. So what is our final answer? What is our final answer? Good. That's good before. That's all I'm giving a chance. How many times, if you're working on that number bond, how many times can you pull 5/5 out of 13? Okay. All right, what do you have as your final answer?
I got 2 3/5.
2 3/5. Did anybody else get 2 3/5? Several. So you agree with that answer. Let's see. I can pull out 5/5 how many times? Well, if I pull it out 2 times, that's 10. If I pull it out 3 times, that's 15. That's too much. 2 times, and that's 10. When I take 10 away from 13, I've got 3/5 left over. So that's 1, 2, and 3/5. Okay, well, that's not bad. This took longer than doing the multiplying. Okay. All right. So multiplication of fractions, especially with unit fractions and a whole number, very, very, very simple. Okay. I thought you would appreciate that after yesterday.
This is easy.
Okay. It really is. Let's do one more, and we're ready to move on. I think, because y'all get what's going on. Y'all get what's happening. Okay. So let's go with staying with unit fractions today. Okay. Don't forget to change your answer if it's improper to the next number. All right, what is our final answer going to be? Final answer going to be. Anybody get 2 1/4? Several? Yeah? Okay.
What was doing disagree?
Okay. Well, what does the improper fraction look like? When I multiply, what do I get first as my improper fraction? Yeah. 9/4. And when we change that, we can pull out 4/4 how many times? 2. Because 4/4 and 4/4 makes 8/4. But I have 9, so I have 1 left over. So that's 1, 2, and a fourth. So that equals 2 and 1/4. Okay. All right. I think you guys are well on your way to being good, very good at multiplying fractions.
We already were.
Okay. Well, to me, this is like the beginning of it. And so, if I mean all multiplying, multiplying all fractions, there's still more to come. But you guys are doing awesome today. Yeah. We will do our exit ticket after our problem set. We'll come back from our break and do our problem set in just a second. Okie doke. So if y'all would clear off boards and put them away.